start with sharing the story that led up to this work. I had just finished working on a segmentation algorithm, and I was faced with the question we all as researchers face: is this algorithm any good? And so I looked through the literature and I discovered that the way it works with cells is often we have some expert draw the outlines of the cells, and then we compare our algorithm against those drawn outlines, and we choose some measure that gives us a score. If the score is good, we have a good algorithm. If the score is bad, we have a bad algorithm. Pretty straightforward. So my challenge using this approach was which metric gives me good scores. But one of the questions not answered in the literature is how do I come up with that gold standard? I quickly realized that if I was trying to create algorithms that reproduced a gold standard that wasn't any good, I was like, what good is my algorithm? So using that as the premise, I started to ask questions of how do I come up with a good gold standard? And I was facing a lot of questions, such as which annotation tools should I use? Who should I have annotate? And given the fact that I know that different biologists draw cells in different ways, should I come up with some technique to combine the different annotations to create a gold standard? So I had all these questions, and I wanted to explore them all. And I hit my next challenge, which is there's no off-the-shelf system where I can test all these things. So for me to come up with a good gold standard would require a lot of effort in developing such a system. So that's the work that led to the system, that's what led to what I'm presenting today. So I'm presenting today a new segmentation analysis approach, a toolbox, as well as some case studies suggesting how to develop trusted gold standard segmentations. So the first take-home point I wanted to drive is when you consider how to build your approach for evaluating a segmentation algorithm, you should consider the steps involved in generating that gold standard. So I call this approach SAGE, which stands for Segmentation, Annotation Collection, Gold Standard Generation, and Evaluation. Pretty straightforward. So the next natural question is, how do you apply that? So we developed a system that lets one use it, and supports, so first in annotation collection, there are many different tools one could want to use. And so in our tool, we developed it to support ImageJ, Amira, Label Me, as well as straight up binary images. So this is just an overview of the system. And moving to the next step in the SAGE process is gold standard generation. So after one collects annotations, one may want to actually combine those annotations into some sort of fused into a single segmentation, which is the gold standard. So in the next part of the pipeline of SAGE, which we support, one can actually collect various annotations and combine them using several fusion algorithms, including thresholded probability maps and stateful. So then, this is just an overview of the system doing that. And then at the end, one can choose either an original annotation to be the gold standard or one of the fused annotations. Diving forward. So then one would choose an evaluation measure. We have many evaluation measures that are supported in our system. And moving to the last part of our work, we developed case studies to talk about how to design trusted gold standard segmentations. For lack of time, I'm going to let you come to the poster to ask questions. In addition, we wanted to run an experiment on you all. So we wanted you to see how good you could create gold standards. So if you come to our poster, we will sit you down, we'll have you draw annotations. We will tell you how good you are at drawing them. And if you have the best one, you'll leave with $20. So that's all for today. Thank you for your time.